So I'm gonna to show you how we'll do amplifier. Okay, so that is the first one thing here. We're gonna to see that the amplifier related to BJT, bipolar junction transistor. Okay, so how you can create an amplifier with the help of the BJT. So let me start with that. Here I will draw one block diagram. So this is your the amplifier. Alright, so this is the amplifier which is related to BJT. Okay, and here the terminal, we need to do a terminal also. So this is the terminal, and now here we need to create a circuit. So we'll create the circuit. So this is your resistance, and this is the connection. Here also a connection. This is your source. This is known as a VS, and this is the source resistance. You can say this is the RS. Okay, and we have to connect this part also. Right, and at this the output terminal we need to connect with the circuit. So I can draw here. This is your the load resistance. So this is the RL. Okay, so this is the RL and this is the IL. All right, so as we know that this is your the two port network. Okay, so I will take this the inside the current, that is the I1, and here this is the I2, and this is the voltage is the V2, and this is the V1 voltage. All right, so we can see the two port network has been created. Okay, and here we have added one. This is the source type of terminal, and this is the load type of terminal. All right, so now we need to get the lot of the thing from this type of the circuit. The first thing we need to see here how much the internal impedance. So we need to see here from this side. So I'll take the next color. So this is your input impedance. So I can see here input impedance Ri. So this is the Ri is your the input impedance. Input internal impedance. Alright, so what is the input impedance here? That is the V1 over I1, and at the output side we need to see here the output impedance. So this is the internal output impedance, which is denoted here with the R0. Okay, so I can say here this is the R0. So V2 over I2. So we got here the two type of the thing, the input impedance, internal input impedance, and output internal impedance. And now we need to see overall input impedance. So from this side we need to see, and this is the R I dash. This is the overall. Okay, so overall input impedance. Right, so this is the RS. So how to do this? This is the RS, and this is the source. So we need to see from this side. All right, so this is the VS, and here we need to connect, or can say replace the whole network by using using this is the RI network. So I'll do this is the RI here. You can connect this to the RI, and now need to see from this side. And so here this is the RI dash. This is the RI dash is you can say this is the RS plus Ri, because they are in series. So that's why I'm writing here this is the Rs plus in Ri. Alright, so from the outside you need to see the same thing, the overall output impedance what we will have there, this is the Rs RL. What is the RL? And you need to replace by R naught. But need to see when you will write the R naught. You need to off the all the independent source, because this is your the Thevenin resistance. So that's why the RVS will be 0, and this is the short circuit when you will calculate the R naught. So you can write here this is the Vs equal to 0. But at this the place you have to replace the whole network by using of the R naught. I can say you will connect like this here, and I can draw like this. Okay, so this is the terminal. We need to connect this the R naught dash. Okay, so this is the R naught, not dash, this is the R naught, and this is the RL. We need to connect this the RL also. So this is the RL, and now we need to see from this side what is that, the R naught dash. So this is the R naught dash. What is the R naught dash? Both resistance on in a parallel, so you can say the R naught will be parallel within the RL. You can also write here R naught RL over R naught plus RL. So we have clear about this the how you will calculate this R naught dash. So you can write like this, the R naught and this the RL is parallel. Now we have calculated the 4 different things. Okay, 4 different things we got here. So we need to erase this part. Alright, so this is the Ri dash, this is the Ri, and this is R naught, and this is R naught dash. But we need to understand this is the internal parameter. For the internal parameter you need to go for the hybrid model, when you will have the circuit of the BJT, what the types of the BJT, whether NPN, PNP, how much that is the collector, common collector, common base, anything you might be given. Then you need to calculate the internal parameter. Our internal parameter is that this is the Ri and R naught. This is the internal parameter. All right, and 2 more internal parameter we need to calculate here by using of the hybrid model. This is the AI and this is the VI. Okay, what is the AI? Is the current gain, and what is the VI? Is the voltage gain. So how you do this, the current gain and voltage gain? As we know that the current gain, the forward current gain, output forward current gain, that is not the forward current gain. This is the input current. So you can say reverse current, or so that's why you can write like this. This is a minus I naught. Now it is in a forward current gain. The both are the forward current gain, means the I2 or the output over input. So you can write the I2 minus I2 over I1. This is your the input, or not the input, you can say this is the impedance. All right, so this is the impedance. No, it is a gain, I'm sorry, this is the gain. So what's the types of the gain? This is the current gain. So this is the current gain. From where? This is the internal current gain. So you can also write the internal. So this is your the internal current gain. Okay, now we need to calculate the VI. So VI we need to go for that. There's the V1, or concept VI. So I will say this is the VI here. So VI is that the V2 over V1, output voltage upon input voltage. This is your the internal voltage gain. So this is the internal voltage gain. So this is your the internal voltage gain. But we need to find out our overall voltage gain. How we'll do this? So overall voltage gain, overall voltage gain. So overall voltage gain here, if you will see, this is the load resistance across, it will have voltage. So what is the voltage? This is the V naught, you can say. So overall voltage gain means the V naught, the output load voltage upon this is the source voltage. So can say VI dash, that is your the V naught over Vs. So we need to simplify this part. You can write like this: V naught over V2 into V2 upon V1 into V1 upon Vs. So this part we have calculated here, so you need to write here, this is the V naught over V2 into Vi into V1 over Vs. Alright, so V naught and V2 is that, what is that? The same voltage, because V2 and V naught are in the parallel, so parallel voltage will be same. So you can write this is the 1 and into V1, sorry, Vi into V1 upon Vs. Now we need to calculate the Vi. I'm writing this. Okay, so this is the V1 upon Vs. So this is the V1 upon Vs. We need to calculate the V1 upon Vs. So at this the input side, we need to go for the V1 upon Vs. So we'll write this is the Vs. We'll make the circuit. So this is the Rs, and we need to replace with its part here the Ri across the V1, and here the current is in I1, and here we can say this is the current Is. Alright, so we can also write the current is in Is. Now what the voltage is V1, so you can write by using of the voltage divider rule. So this is the V1 equal to Ri into Vs over Ri plus Rs. Alright, so you can simplify this part like this. This is the V1 upon Vs Ri over Ri plus Rs. So we need to put this value and we'll get this part. So you can write is the Vi dash equal to Vi into Ri upon Ri plus Rs. So we got there the overall voltage gain. Now we need to calculate here overall current gain. So overall current gain AI dash is that what you can see here, the IL and this is the IS. So we can write this is the IL, the forward current upon forward in output forward current upon input forward current. So this is the IS. So we can simplify like this again: IL upon I2, I2 upon I1, I1 upon IS. So you can see this is the I1 and IS is the same thing. I1 and IS is the same thing. We get cancel here, and we can write here the 1, and this is the I2 over I1 into IL upon I2. Now we need to see here the IL is that IL equal to minus I2. Alright, so you will put here the value, sorry, here we need to put the value that is the minus 1 into I2 over I1. So what is the I2 over I1? We have calculated here the current gain. Already we have calculated here. This the minus I2 upon I1 is your AI. So you need to replace with this part, and we'll get this the 1 is here the 1 is nothing but is the 1 here. So that is the 1 multiply minus I2 over I1, and this is the same thing, is the AI. So finally we got this is the AI, and this is the AI dash equal to AI. Alright, so what we have seen here as a, if there is no any parallel kind of the resistance, then you have to replace this part, and you can say directly the current gain will not going to be changed, because if you will have the resistance in this network in parallel, with that the RL, then you can say the current will be divided, and then your the current gain will be changed. If you will not have, if you will not have the RS, then you can say, what you can say, your the voltage gain not going to be changed, because the voltage always divide in your series combination. But in the parallel, if the parallel network is, it means you are the resistance in the parallel, then you have to divide, then it will divide your the current, and it is only that the possible the current gain will be changed. So here the current gain is not going to be changed, overall current gain and internal current gain, it's the same thing, and but voltage gain is changed. Okay, so this is the BJT amplifier. Here the internal parameter, the four parameter we got here, there's a four parameter: Ri, R naught, AI and Vi. We need to calculate by using the hybrid parameter model, or can say R pi model, hybrid pi model. You can you can use any of them. So yeah, you will have a lot of the thing. So you can go for it, and overall the voltage gain, current gain, and resistance or impedance, anything you need to calculate you by using of this same method. All right.